Hello, it's John Everest again, and this is the second video in a discussion on high dynamic range images. In the first one, I kind of contrast high dynamic range images against sort of JPEGs and such, and we established that there is a lot of useful information buried in the high dynamic range image. What I want to show you now is what can we do with that data. So we can represent the data rather than as a trying to make it look like a photo, like as we would experience in the real world. We can say, show me the lit data in false colors, pseudo colors, so I can start to understand what is happening in the scene. So here we are looking at the candelas per meter squared. That is the experienced brightness of all the surfaces. And not surprisingly, we're seeing that the window frames or the window recesses are very bright. The desks in front of the windows are bright. The downlights on the right hand side are bright. We can understand the general luminous environment across the space. We can also look at what's called lux, and a lot of the lighting standards prefer the information presented in lux, and this is the light falling onto the surface, not the light sort of leaving the surface and going into our eye. It's actually the light falling onto the surface. So if we want to sort of isolate the data of just sort of light of sorts independent of the reflectances, we can do it this way. Obviously, the reflectances will influence the overall quantity of light in the room. But if you just want to know, well, what light is falling onto the desks, regardless of what color they are, here's a way of doing that. We can have all the the contours and the extremer points, and usefully, we can start to isolate sort of pixels of specific brightness. So what I've done here is say, highlight to me all the pixels that are brighter than 150 candelas per meter squared. And I use that figure 1500 candelas per meter squared, because it's at that point you need to start thinking you may have some glaring surfaces. Not guaranteed, but you've done a very coarse analysis, and very quickly we've found these kind of things, and now we might want to look at those areas in a bit more detail. We can be a bit more specific, and we can say, well, if we were looking at the board, the blue circle, show me where might I sort of experience glare in the scene if I was looking specifically in that direction. The threshold I've used is areas 5 times brighter than the area I'm looking at, which is as we might start to experience discomfort glare. And it's saying it's not half as bad as before, but that analysis is only specific if I am looking at that board in that direction. If I look anywhere else, it would be a different set of results. And it's for that reason I prefer that just coarse analysis, because you'll need to start firing blue dots all over the place to do that. It's very difficult to get meaningful results. And so that's like looking at the information we can sort of pull out, but we can also sort of pull the information out and reformat the presentation of the photorealistic image. And I give you this example here that if we had a classroom where we've only actually switched on the lights at the front of the classroom, just 2 lights on in a classroom roughly 8 meters by 8 meters. If I just display that high dynamic range image, just tone map it so I can see it on my monitor, it gives me this image. So it is implying in this image that if I only switch on 2 lights at the front of the classroom, this is how it would look. And to me, that gives me the impression it's not perfect, but I kind of feel like, yeah, I could sit there, I could probably read a book, I could comfortably walk around the space. But I think we can all say, like, if you just light one sort of wall of a room, it will not look like that. What we can do is, because we have the physical data buried in every single pixel, we can start to simulate how we would experience that scene. And the first thing that would happen is, if an area was very dark, we would lose the color saturation in the dark areas. So we would simulate the scotopic response of the eye. So take a look at the colors, the reds and the blues of the chairs. Under dark conditions, they will darken right down. The next thing that would happen is we would lose the acuity of our eyes, so we would not see edges as sharp as if they were well lit. So take a look at the chairs at the front, the red and the red chair, for example, immediately front, and you see when we apply that function, it's subtle, but it is there. It blurs out slightly, and that would happen in low luminances. And next, if we have a very bright area relative to the rest of a scene, we'll start to get some internal scattering in our eye. And that's just fancy talk to say, you'll start to get sort of a haze and a veil around the very bright areas. So again, look at the board where all the light is focused and notice how it sort of gets a haze around the front of the board. And so now you can start to see that that's actually quite an uncomfortable scene. But the most obvious bit is it's still implying that everywhere would be adequately lit. But we can say to we can say to the software I'm using here is Radiance. We can say to Radiance, take um, balance based on the luminous values. Represent this image with appropriate brightnesses as we might experience, and that's what we get. And that is probably how we would. It's a good approximation of how a room would look if we only had the board lights on at the front, and that may guide a design team to say, well, I don't think we want that. We're going to need to have some, we don't want to switch the lights off. We want to dim them down, and we can very quickly arrive at that, and we can express it to non-technical clients. We can show the coloured images and such and the numbers, but it's understandably our non-technical clients might not understand that, and here is a very useful way to, with confidence, communicate those concepts. So I'm going to cut this presentation here. On the next one, I'm going to show you how we can actually start to sort of simulate some sort of switching and dimming functions using high dynamic range images. I'll see you on the next video.